Team, so I hope you all are well. Today we're going to continue our journey of volume and surface area. We're going to look at volumes of pyramids today. So a pyramid is named by the shape of its base. So as you can see, each of these three pyramids have that triangular shape, and the faces are triangles that meet at a apex, and the base determines the name. So this is a square pyramid because the base is a square. This is a triangular pyramid because the base is a triangle, and a rectangular pyramid because the base is a rectangle. Now, there's some language that is going to be used. Here is the perpendicular height. So the blue line represents the distance that goes from the apex to the center of the rectangular base, whereas this is the slant height. Now, the slant height you need to imagine is the line that runs down the front face of that pyramid. Whereas the perpendicular height is, imagine that you're standing at the top of the apex and you're looking directly down, like straight below you. That's the perpendicular height. Whereas the slant height is, imagine that you're sliding down like the slippery dip of like the face. Whereas this is dropping straight down. That's perpendicular height. This is slant height. As you can see, they do form a right-angled triangle where the slant height would be the hypotenuse and this side is the perpendicular height. And the reason why I'm naming those two different heights is because to find the volume, it's actually a third times the area of the base. So whatever the shape is, times the perpendicular height. So that's the one that runs directly down. Some questions will trick you and it will give you the slant height. But in order to find the volume, you actually need the perpendicular height. So let's have a look. Here we've got some examples. Find the volume of each pyramid. So we'll start off with this one. As you can see, this is a rectangular pyramid because the base is a rectangle. So for the area of the base, because it's a rectangle, it's literally just 20 times 25, which is 500. Okay, so therefore for the volume, it's equal to a third times the area times the height. So a third times the area of the base, which is 500, times the height, which is 30. So as you can see, this directly points to the height, okay, and that's the base. Putting that all into your calculator, you get 5,000, and because we're working in volume, it's millimeters cubed. So it's that easy. All right, this next one's a bit of a weird looking one, but I've highlighted the base, it is a triangular pyramid. As you can see, this line represents the perpendicular height, okay? That line is showing you that this length across the base is actually 7 meters. So the reason why it's pointing that out is because, remember, for the volume, we need the area of the base. And because it's a triangle, remember the area is the base times the height, all divided by 2. Actually, this should probably be labelled like that to show you that it's the perpendicular height of the base. So you just want to kind of focus on this triangle here as the base, whereby that 7 represents the height, the perpendicular height of just the base, and then 10 is the length. So for the area of the base, we're going to go 10 times 7, and we're going to divide it by 2. And we get 35 meters squared. So that's the area of the triangular base. So for our volume, it's a third times the area of the base times the height of our pyramid. So it's a third times 35 times the perpendicular height now is that one that runs directly from the apex straight down to the base, and that's 8. And together that gives us 93.3 repeater meters cubed. Okay. Alrighty. So question number 2. Find the capacity. So remember, it's kind of helping you because it does say to the nearest milliliter. So capacity is the amount of like liquid something can hold. versus volume is the amount of space it occupies. No, sorry. Yeah. Why did I just get so confused then? What did we write down for our definition? Yeah, the volume is the amount of space it occupies, and the capacity is the amount of fluid, like liquid or gas, it can hold. I was getting confused with surface area. Okay, so for this one, we want to find the capacity. What that means is we want to work out how many milliliters this thing could hold if it could hold a liquid or a gas. So it tells you it's a square pyramid, so that means the base is a square, and it tells you the base edge is 64 millimeters, and it has a slant height, so this is what I was talking to you about before, a slant height of 40 millimeters. So that is this length that runs along the front of the face. So for the volume, we want the perpendicular height, which it doesn't give to us. However, we can find the perpendicular height by imagining that this triangle here, you can draw it out of like the picture, I guess. So let's do that. So here's our triangle where you've got this is the slant height. Whoops. And this is the perpendicular height from that triangle. And then the base is obviously that length there. So if this is 40, this is the height that we want for our formula. So having a look, we can use Pythagoras' theorem to work out what this length is going to be. And for that, we're going to need this length across the bottom. Now, as you can see, remember I told you the perpendicular height drops from the top directly into the center of the base, which means that this length, it must lie in exactly the middle. So if that's 64, because it's a square, that's also 64, that means that that length between there and there has to be 32. And using that information, we can now find out what the h is going to be. So remember, Pythagoras' theorem is c squared equals a squared plus b squared, where we've got 40 as our hypotenuse. A squared is what we're trying to find, so let's call it h, plus 32 squared. Remember, we're rearranging it for h, we just subtract 32 squared from both sides. And we get h squared is equal to 40 squared minus 32 squared. That gives you 576. But we don't want h, we don't want h squared, we want h. So we take the square root. Remember, it's plus or minus. Remember that, but because it's height, it's a distance, it has to be positive. So it gives us 24 millimeters. So now we've got our perpendicular height. We can continue on with our volume. So remember, for our volume, we want the area of the base. And because it's a square, 64 times 64. Just going to move that down a little bit. And that gives us 4,096. And for the volume, lucky last thing, remember it's a third times the area of the base times the height. So a third times 4,096, because that was the area of our base of our square, times the perpendicular height, which is what we had to find. So 24. And that gives us 32.768 centimeters cubed. Whoops. However, we don't want volume, we want capacity. And if you remember, for capacity, 1 milliliter is equal to 1 centimeter cubed. So straight away, it's already in centimeters. Oh no, sorry, it's in millimeters, isn't it? My bad. So that actually comes to 32,768 millimeters cubed. but we want to convert it to centimeters first to help us find the capacity. So from this many millimeters, remember 1 millimeter cubed, and you can use your conversion charts, don't have to remember this off the top of your head. Centimeter cubed is actually equal to 1,000 millimeters cubed. So to get this into centimeters cubed to help us do the quick conversion, we just divide it by 1,000, which is why we get 32.768 centimeters cubed. And since 1 milliliter equals 1 centimeter cubed, we can then say the capacity is therefore equal to 32.768 milliliters. And because it's said to the nearest milliliter, we'll just say it's approximately 33 milliliters. There you go. So quickly going through this, because it said the capacity, what we needed to do was find the volume. In order to find the volume, we needed to find the perpendicular height. We used the slant height as a triangle, and using Pythagoras' theorem, we found h, because that length across the bottom is 32, as it's half of the length of the base. Going through using our volume formula, we find our volume. We needed it in centimeters cubed. You could have, I wouldn't have minded if you went straight from millimeters cubed and looked up the conversion to go from millimeters to milliliters. That would have been fine as well. But we did it the long way and went to centimeters cubed, then to milliliters. All right, last question. If the volume of a square pyramid is 100 centimeters cubed and its height is 12 centimeters, find the length of its base. So, because it's a square pyramid, remember, if we're talking about volume, the volume is equal to 1/3 times the area of the base times the height. Now, let's just say, I wrote it twice. Let the length, because it's a square pyramid, right? We're going to say let the length of the base be, let's just say it's x. That means for the area is going to be x times x, right? Which is x squared. So that's going to help us, because if in our formula, we want to find the length of the base. We already know the volume is 100, so using our formula, we know the volume is 100 centimeters cubed, and it's 1/3 times the area of the base, which is x squared, times the perpendicular height, which we know is 12. Now what we've done is we've just created an equation. You could have, instead of saying let it equal x, you could have just gone ahead and just said it's 100 equals 1/3 times a times 12. That wouldn't have mattered, right? Because then you would have gotten down to this point and said, well, that's what has happened there? That's fine. Cleaning it up, we can go, well, 1/3 of 12 is 4. So we've got 100 is equal to 4 times x squared. Or if you feel more comfortable thinking of it this way, same thing, 1/3 of 12, clean up the numbers, is 4a. We want to get, because this is representing area, so we want to get that by itself, I guess. So on both of these scenarios, you would go through and divide by 4. $100 divided by 4 is 25. Whoops. Okay. So now, because we defined the length to be x, this is x squared. What we want, I'll just rearrange it, is x, right? So the same thing, we go through and we take the square root. And we just get 5 centimeters. If you preferred the A, what you'd have to say is, remember, because we're talking about, it tells you it's a square pyramid. Think of this as obviously a square where the area is 25. So this means that that length and that length have to be the same. So then you could come down to the fact that the length would still have to be 25. Okay. Alrighty. Hope that made a little bit of sense for you. And yeah, just follow through these notes and good luck.